Quadratics unit, summative review. This is objective 3, solving a quadratic equation by completing the square, factoring square roots, or using the quadratic formula. The discriminant will be used to determine the number and the nature of solutions. So you're given the quadratic formula. First question here is, give the next line in this solution by completing the square. Well, to complete the square, we need to take half of the b value and square it and add it to both sides. So if we take, first, we take 1/2 of the b value, we get 4. And if we square it, we get 16. So the next line here would be x squared minus 8x plus 16 is equal to 10 plus 16. That is the next line in solving by completing the square. The whole reason we did that would be the second line would be to do x minus 4 quantity squared is equal to 26, and then simply solve using square roots. The second problem here, write the quadratic equation in standard and vertex form, which has a vertex of 1, 5 and contains the point 680. Well, remember that we have y equals a x minus h quantity squared plus k, where the vertex is hk, and then the other point is our xy. So we have 80 is equal to a times 6 minus 1 quantity squared plus 5. This is 80. Then we have a 6 minus 1 is 5 squared plus 5. 80 is equal to a times 25 plus 5. Subtract 5. 75 is equal to a times 25. This tells us that a is equal to 3. If we know what 3 is, the standard form is just y equals 3 x minus 1 quantity squared plus 5. Whoops, sorry, that's not the standard form. Let's see if I can do this. That's the vertex form. My bad. Whoops. The standard form, should switch these around. The standard form, I have to FOIL this. So I'm going to get x squared minus 2x plus 1. I have the plus 5 down here, but this is all multiplied by 3. So then I'm going to put this up here. I'm going to have 3x squared minus 6x plus 3 plus 5. Combining my like terms makes that 8. So y is equal to 3x squared minus 6x plus 8. That would be the standard form. Not too bad so far, right? Find the equation of the discriminant. Find the value of the discriminant for the following equation. Well, remember that the discriminant is equal to b squared minus 4ac. Well, before I can do this, I have to get this in standard form. So I subtract x from both sides, or I could even add to this side. I'm going to add 2x. So this will give me 3x squared. I'm going to subtract 8x minus 8x minus 28 is equal to 0. Now, b squared is 64 minus 4 times a times c. So now I've got all of this, and it winds up being 400. The value of the discriminant is 400. Remember, you should not have the square root. Now, The next one over here, if the value of the discriminant is 25, then the quadratic equation has, well, this is a perfect square, and it's real. So I'm going to get 2 real, and because it's a perfect square, these are going to be rational roots. All right? Good job. Let's go to the next line. Okay, which of the following is true about this equation? We're going to circle all that apply. So, what do we do first? Well, first we have to find the discriminant. So, to do that, we can maybe bring up our calculator. Sorry, my husband is he's blowing leaves. So, hang on just a second. Okay, that's a little bit better. To find the discriminant, we've got b squared minus 4ac. We press enter, and it turns out to be 1600. Well, since 1600, if I want, and if you're not sure, I know that 1600 is a perfect square, but I could also do the square root of that answer and find that it is a perfect square. That tells me that I have 2 roots, they're real, and they're rational. So I would circle all of those. Now this next one, solve 10x squared plus 8x minus 1. I need to see first, are there factors of negative 10 that add up to 8? Well, there aren't. So I'm left with doing it using the quadratic formula. So x will be equal to negative b plus or minus the square root of b squared, which is 64, minus 4 times a times c, all over 2 times a. I get from here, I'm going to put this over here, I'll get negative 8 plus or minus the square root of 104 over 20. 104, I can take 4 out of it, so that'll give me negative 8 plus or minus 2 square root of 26 over 20. At this point, I still need to simplify. So what I'm going to do is get rid of this. And then 2 goes into everything. So you get negative 4 plus or minus the square root of 26 all over 10. That's your answer. Oops, this is a negative. Okay? Now this next one is really easy. The correct solution set for the equation 5k minus 3 times 6k plus 1, it's already been factored. So you just set each factor equal to 0. 5k minus 3 is equal to 0. 5k is equal to, k is equal to 3. K is equal to 3/5. The other one, 6k plus 1 is equal to 0. 6k is equal to negative 1. So k is equal to negative 1/6. When you solve by factoring, that's one of the easiest ways to solve, especially if it's already factored. Okay, next up, I need to solve 7x squared equals 19x plus 6. First, you have to get the equation set equal to 0. So I have 7x squared. I'm going to subtract 19x from both sides and 6 from both sides to set the equation equal to 0. Then I'm going to look to see, are there any factors? 7 times negative 6 is negative 42. That add up to negative 19. Hopefully, you see that there are 2 and negative 21. Those multiply to negative 42 and add to negative 19. Now, remember that the value of A is 7. So I have to consider how I'm going to work 7 into these two numbers. So I bring the 7 over and I make my x into a star. Now I have x plus 2/7, that's reduced, and then x, negative 21 over 7, that reduces to 3. Over here, if I'm factoring this, this becomes 7x plus 2, and this is still x minus 3 is equal to 0. This means either 7x plus 2 is 0 or x minus 3 is 0. So my solutions, x equals negative 2/7 or 3. You set each factor equal to 0 by itself. So 7x plus 2, I would set that equal to 0 and solve for x. X minus 3 is equal to 0 and solve for x. Pretty easy. Okay, now we're down to the last two in this section. For this one, x minus 8 quantity squared minus 7 is equal to negative 25. Don't multiply it out. You can solve this one by square roots. If I add 7 to both sides, I'll have x minus 8 quantity squared is equal to negative 18. Yeah, we learned that you can't take square root of a negative number, but then we learned it's imaginary. So we can. So x minus 8, I take the square root of both sides, is equal to plus or minus the square root of negative 18. X minus 8 is equal to plus or minus the square root of 9 times negative 1 times 2. I'm just separating it out so you can see how I get simplest radical form. X minus 8 is equal to plus or minus 3i. The square root of 9 is 3. The square root of negative 1 is I. And then this 2 stays inside. Now to get x by itself, I add 8 to both sides. So when I add 8 to both sides, and I come over here and give myself just a little more room, I'm going to have that x is equal to 8 plus or minus 3i square root of 2. Those are my solutions. I have two imaginary solutions. And I didn't have to go through the whole bother of multiplying or foiling out x minus 8. Number 10. This is another one I can solve by square roots. If I subtract 11 from both sides, I get negative 3x squared is equal to 6. Divide both sides by negative 3. X squared is equal to negative 2. Then I take the square root of both sides. X is equal to plus or minus the square root of negative 2. X is equal to plus or minus I square root of 2. And I'm done. That's it for objective 3. If you have problems or questions or you're still unsure, copy down these solutions, bring them in, and show me where you get stuck, and I'll help get you through it. Have a good day.